In this video, I will explain how the dipole moment behaves for diatomic molecules and polyatomic molecules. Diatomic and polyatomic molecules. So for the diatomic molecules where two atoms are involved, the dipole moment depends upon bond length and electronegativity. If it is a polyatomic molecule, then the net dipole moment depends upon individual bond dipole and spatial arrangement of the molecule as well. So let us try to understand these terms with the examples. So if we take example of the hydrogen molecule H2, it is a diatomic molecule because there are two atoms, right? Hydrogen, hydrogen. But there is no dipole moment in this particular molecule. But if you look at the HCl, there is a dipole moment between hydrogen and chlorine. And that dipole moment depends upon bond length. So length of this bond that is created between hydrogen and chlorine and electronegativity. Okay. So chlorine is more electronegative than hydrogen, and that's why dipole moment is shown like this. The arrow pointing from hydrogen to chlorine. But in case of this H2 molecule, both the hydrogen atoms have same electronegativity, and that's why there is no dipole moment. But in HCl, since chlorine is more electronegative, there is a dipole moment pointing from hydrogen to chlorine. Now let us look at the polyatomic molecules where there are more than two atoms involved in the molecule. So in H2O there are three atoms, right? Two hydrogen and one oxygen atom. That's why it is polyatomic. And in this molecule there are two dipole moments as you can see over here. This is first one and this one is second dipole moment. If we look at another example, CO2, we have got carbon atom here in the center and then there are oxygen atoms on each end. So here also we have got two dipole moments. But if you look at these two examples, H2O and CO2, even though there are three atoms in each of these molecules, dipole moment is different. The direction is also different. In a CO2, since the molecule shape is linear, these dipole moments are equal in magnitude but opposite in direction, so they cancel out each other. So that is what spatial arrangement is all about. So how the atoms and molecule is arranged spatially, that will decide how the dipole moment will behave for that particular molecule. In case of H2O, net dipole moment will be in upward direction like this. So we basically take the sum of these two dipole moments. So in this case, net dipole moment is not equal to zero because of the spatial arrangement of the hydrogen and oxygen atoms. H2O is not a linear molecule, okay? And that's why dipole moment is also not zero. That's it. Thanks for watching.